Good morning, my stats folks. Miss Rice can't be here today in person, but I'll leave you my voice and the next set of notes because we have to move on with or without me. Should be back tomorrow, so we'll fill in gaps if we need to when tomorrow comes. So we have finished 5 chapters that were about basically 2 things. You had categorical data, very little you can do with that. And then we had a whole lot of information about quantitative data in one variable. So in this next unit, chapters 6 through 9, we move into the bivariate data, which is the 2-variable quantitative. Now, we've already seen 2-variable categorical, so let me just make a connection here. We've already looked at things like segmented bar charts and side-by-side circle graphs and side-by-side bar graphs. These are the ones that compare 2 different categorical variables, like which region you're from. Are you from the Northeast or the Southwest? Those are categories, not quantitative. And something like political party leanings. So in the Northeast region, this percentage of people were conservative. These percentage consider themselves moderates. This percentage considers themselves liberals. And then we have a different conglomeration of those folks in the Southwest. And the primary purpose of these graphs are to look at the differences and see if there's something interesting going on, like independence, which we will eventually do with quantitative data in the long run. So we've really already dealt with 2-variable or bivariate categorical data. Very little you can do with it. This is pretty much the long and short of it. So there's a lot more to know about quantitative, which was true about the 1-variable data. So that's what we're going to dig into now. So we start with the basics. There's only one graph. Only one, ever one, never 2, never 5, one graph and one graph only for bivariate data. And it's the scatter plot. You've seen those before. That's not new business. You've learned some things about scatter plots. You've learned some things about lines of best fit in the past. Some of those things are good things that we will reiterate in this class. Some of those things are, some of those ideas probably need to be tweaked. Some of them need to be thrown out and rebuilt, and that's what we're going to do. So in this case, we have a scatter plot of husband's age and wife's age for a whole bunch of married couples. And we see that there's a strong linear pattern that's popping out here. And what we want to be able to do is compare 2 quantitative distributions in a scatter plot and look for those patterns and be able to put the right terminology with them. So today is a learn how to cuss about 2 variables and use the correct terminology kind of day. So moving on to the next slide, we have some new vocabulary. This is absolutely different than what we learned in algebra. In algebra, we learned that the x is called the independent variable and y is called the dependent variable. We never, ever, ever, ever use those terms in this class. Let's make a note first of all. Independent, I may need a new pen. This one's not doing very well. Let me trade pens before we go any further. Independent and dependent variables, which we used in algebra class, in the world of statistics are an absolute no-no. We don't use them because independent dependent implies that y depends on x, and that's not necessarily true. That we require some testing to even see if that might potentially be true down the line. So this implies a cause-effect relationship that we cannot necessarily agree to. So we changed the vocabulary in this class to x is called the explanatory variable or predictor variable, and y is called the response variable. And we think about how y responds to x, or y can be predicted by x. X is the predictor of y, but doesn't necessarily cause y. So we're going to stick to these terminologies. These are very explicit terms that we have to learn to use and use well. Do not use independent, dependent. They will get you into all kinds of trouble. Take those out of your vocabulary at this point for this type of data. The word association we've seen that before, is a general term that means I see a pattern in statistics. Don't make more of it than that. It just means there is a pattern that is discernible in that scatter plot. You guys already know, I'm pretty sure, that if you have a positive or increasing pattern, when y increases as x increases, so the points generally go up and to the right, that's a positive association. Negative goes down, y decreases as x increases. And whenever we talk about the positive and negative in context, we're always going to talk about the increasing and decreasing. So the wife's age increases as the husband's age increases, or the wife's age decreases as the husband's age increases. So we always want to talk about that association in context. Strength is about how much scatter is going on in that scatter plot. And so less scatter means we have a stronger association. It's kind of like spread. So when we talk about strength, we're really talking a lot about how spread out those data points are from the center of the pattern, if there is a pattern. Let's get more specific. When you are asked to describe the association between two quantitative variables, it's very much like the question, describe the distribution, that we had in the first unit. To describe the distribution means to cuss. We talk about shape, center, spread, unusual features. This is very much the same. We talk about shape, but we call it form for two-dimensional data. So instead of talking about unimodal, bimodal, skewed, or symmetric, we talk about whether that set of points is straight or linear looking, or whether there's a curve. You can use the word curved, or you can use the word nonlinear. Those are interchangeable. And if it's curved, we don't care what kind of curve it is. We don't care if it looks exponential. We don't care if it looks quadratic. We don't care if it looks logarithmic. We don't care if it looks like a power function. We just care about, is it straight or is it curved? Is it linear? Is it nonlinear? That's all we care about. Don't make more of it than that. And then there's also there's not a pattern at all. If you just have a cloud of points that looks like a swarm of bees with no discernible pattern, you say there's no discernible pattern. In the event that there's no pattern, you don't have to say anything else about it except give the context. So you skip to the bottom. If you have some discernible form, linear or nonlinear, then you would have to talk about a direction. In general, is it going up or is it going down? Sometimes the direction changes and you have a set of points that goes up and then turns and goes back down. If it does, you have to say that. Between x is this and x is this, we have a positive association. And between x is this and x is that, we have a negative association. So if you have more than one going on, you have to talk about both. So direction, there's not really anything that links to in the one variable data. Form is like shape. Direction is something that's specific just to two variable data. Strength, on the other hand, is kind of like talking about spread with the univariate data. Strength could be strong, could be weak, could be very strong, could be very weak, could be moderately strong, could be moderately weak. And there's not a hardcore defined how weak is very weak, how weak is moderately weak, how weak is just weak. It really is a gut instinct call. And sometimes it's hard to call and you just have to go with your gut, and we might disagree. I might say it's weak and you might say it's moderately weak, and we could probably get by with that because we're not nailing it down according to a number. We're nailing it down according to what we're looking at and what our gut instinct is. Then, as always, we're going to talk about unusual features. Clusters of points, clouds of points, outliers, although we don't officially calculate these. That would be kind of a pain, by the way, because you'd have to find outliers in the x direction and you'd have to find outliers in the y direction. So you'd have to find IQRs for both variables. You'd have to multiply by 1.5 for both variables. It's a lot of computation. Nobody ever does that. We don't care about that in this realm. Maybe in some hardcore upper level statistics courses, computer programs might be used to determine outliers. We only care about what appears to be an outlier. So we're going to use some weasel words for those. And if there's a change in direction or change in form, then we would mention it somewhere in our analysis. And as always, the biggest, most important one in the big larger font with the bold letters is you have to have context. When you describe an association, you have to mention one of each of those things. Now, unfortunately, F, D, S, U, and C do not nicely form the word cuss. They might form FUDS, F-U-D-S, FUDS, F-U-S-D, fussed. You could fussed over the data. So that might work. So if you need some sort of mnemonic device, whatever you want to use is fine. We don't really have one that we all use. Instead, what I normally do is teach you to write one magic sentence, and that's on the next slide. The magic sentence. Fill in the blanks. You see a scatter plot, and you're asked to describe the association. You write, there is a, and then you fill in a strength word. Strong, weak, moderately weak. Direction, linear, not linear. Positive, negative. Form, linear, non-linear. Association between X in context and Y in context. So for the graph of the husband-wife ages, I might say there is a strong, positive, linear association between husband's age and wife's age. You fill in the blanks. Learn to write the magic sentence. So fill in blanks with words. Yeah, this is not a good pen either. On the previous slide. You will do so much of this, by the time we finish this course, you can say this sentence in your sleep. It will not be a real stretch. Chapter 26 wraps back around to this idea and does some hypothesis testing with it. When we get to chapter 26 and we've not written this sentence for a few months, you'll still remember it if you've written it enough times. Now, what not to say. This word correlation that I've already bled red on some of your papers and some red ink pen before, some of you have already tried to throw that one out. You don't know what it means yet. You may think you know what it means yet, and lots of people abuse that word. Psychologists are the worst because they think correlation and association are the same thing. They are not, and we get in big trouble for misusing words in this class. So do know that those terms are not interchangeable. You cannot use the word correlation lightly. So until you learn what it really means, and we'll talk about that tomorrow, don't write it on your paper. And once you learn what it means, only write it when it's appropriate. Association is a general, I see a pattern. Correlation, much more complicated. We'll come back to it later. All right. So, let's look at some associations. We've already talked about the positive one. There's a strong. Well, I think it's strong because if I put an oval, pretend that's beautiful, around all the data, it's pretty long and skinny. So that's a pretty strong positive. That oval goes up from left to right. In general, Y gets bigger as X gets bigger. Strong, positive. It looks pretty straight, linear association between husband's age and wife's age. Negative association might look like this. If I put an oval around that cloud of points, it's not quite as long and skinny as the other one, but it's still fairly tightly packed. It's not, if I put an imaginary line down the middle of it, the spread of points around that line is not real extreme. They're pretty tightly packed together. So I would probably say here that there is a fairly strong negative going down from left to right. As elevation increases, temperature decreases. The higher up the mountain you get, the colder it is. There is a fairly strong, weasel word, negative linear, this is pretty straight, association between elevation and mean annual temperature. Okay, if I try to put an oval around this, it's not really an oval. And I have this fella over here. He's at like about 25,16-ish. He's real different than everybody else. So I'm probably not even going to include him when I try to wrap an oval around this set of data. So we've got some interesting things going on here. First of all, if I divide that cloud from left to right, kind of in half-ish, there's a curve there. That's a curved set of data with an outlier. So I want to make sure that if there is a curve that I see it, because curves are trouble. Curves we can't do any good statistics with. Everything we do good statistics with has to be straight. So these are bad news. There is a, well, let's see, it starts out pretty weak, and as we get farther to the right it gets stronger, it gets skinnier, but only because there's very few people that can do that many push-ups, evidently. So it really just tapers off here because there's not as much data from the looks of things, not very many people out there. So these are kind of in the horizontal direction. They look sort of like interesting, maybe some potential outliers out here. But there's a lot more spread from left to right than there were in the last two. So I would say at best, this is a moderately weak association. So we would say there is a moderately weak, or you can even say weak if you want to go that far, negative, things are going down, curved or nonlinear association between number of push-ups and how long it takes to run a mile. Then I would write an extra sentence because I have an unusual feature. There appears to be an outlier at approximately 20 push-ups and 16, and I don't know what my units are, maybe minutes, 16 minutes to run a mile. That probably is reasonable. So you would mention this outlier usually in a separate sentence.
Parking tag 28, a white Suzuki needs to be removed from band practice lot at this time. Parking tag 28, a white Suzuki needs to be removed from band practice lot at this time. Thanks.
It still doesn't end even after school goes out. Okay, so where was I? I've lost my train of thought. Oh, I know what I was going to say. With the two variable data like this, normally if we don't have unusual features like outliers, it's okay to not mention them. So if you don't mention them, you won't be penalized. If you have them, you need to talk about them. And last but not least on this page, we have a cloud of points. And these appear to be fairly linear, but they're pretty spread out. There's a lot of scatter there around that center of the oval. So I would probably say that there's a weak, or at best moderately weak, positive, linear association between grip strength and arm strength. Done. Outlier, again, is somewhat loosely defined. If it looks different from the rest of the group, it's going to be a potential outlier. So in this case, I might say, because all of this data has a really nice type pattern, and this guy appears really, really different, that there appears to be an outlier at approximately 50, 50. Make sure when you mention an unusual point that you nail down where it is. You have to tell where you're seeing that point, so be specific, as an estimate will do. All right, so this one is actually an outlier in both the x direction because the center of the rest of the points is here, so it's far to the right and far up from the rest. So we think of this as being an outlier both in the x direction and in the y direction. This set of data is definitely curved. This one is not terribly far from the center in the x direction, but it is a little bit lower in the x direction than the y direction. It's Never a dull moment, right? So it's a little bit higher and farther to the left than the center of the data. So this one seems to be an outlier both to the left and up. And this last little chunk here, this is a different kind of outlier. We're going to name these outliers in a later chapter. This is where the bulk of the data is, and then you have this guy way up here. This guy's different than these other two are because this one actually lines up with the rest of the data. The rest of these, if you look at the overall pattern and the overall pattern, they really depart from the overall pattern. So they give us a different kind of trouble than this guy right here does. And there will be a whole chapter, chapter 8, about what kinds of trouble each of those cause and how to appropriately talk about them. For now, we just want to say those appear to be outliers. Those are unusual and different from the rest of the points. So, to summarize, we're going to end with this one. If we have a set of data, let's see, we have an association, we think, between the size and strength of muscles measured. Research is investigating the association between size and strength of muscles measured forearm circumference in inches of 20 teenage boys. Then they measured the strength of the boys' grips in pounds. Their data was plotted. So we have arm circumference here. We have grip strength here. Describe the association. Okay. It seems like, with the exception of this fellow right down here, who seems to not be following the same pattern as everybody else. We have a big arm, not a lot of grip strength. With the exception of that one, the rest of these all seem to kind of fall along a pretty predictable pattern. That pattern, this guy kind of pulls that end up, so maybe I should make that look more like that. That's reasonably straight. There might be almost a start of a curve, but if you took out that fella, it doesn't look curved at all. So we're not going to let that really change the shape because it's an outlier. So if I drew an oval around just this part, it definitely looks pretty straight. So I would say something like that's a fairly strong. So a moderately, I think I'm going to have to retire this pen, strong, linear, that's not an L, linear association. I forgot a word, didn't I? I'm not having a good time. Let's see. I need to also say positive. Positive. Now, I could squeeze it in another place, but I want to kind of get in the habit of saying it in the right order. There's a moderately strong, positive, linear association between arm circumference and grip strength If we learn the magic sentence, we get all the parts, and we make sure we cover context. We have a couple of unusual points. Let's mention those in another sentence. There appear to be outliers. Got some weasel words there. Appear to be outliers at about this lowest one here looks like it's at about 14,20, and a good estimate will nail down where you're looking. And this one looks to be around 15,80. Done. So today we learned to write the magic sentence and make sure that we use the right vocabulary. Stay away from the word correlation and you should be fine. Your assignment's on the next slide. Work on that for the rest of the period, and tomorrow we will move on.